MCEN 1131 Engineering Mechanics, Statics, Structures and Members. A structure is a connected system of members designed to support loads or transfer forces. A wrench is an example of a structure. Trusses. As previously shown, a two-force member has forces acting on each end. These forces line up with the member and cause either tension or compression. A truss is formed if several two-force members are joined in one or more connected triangles. Each of the members is pinned at either end, and if carrying a load, is either in tension or in compression. As the diagrams here demonstrate, the direction of the member indicates the direction of the tensile or compressive force in the member acting on the joint or the pin. When dealing with trusses, we assume that all loads are applied at the joints and that members are joined together by smooth pins. Note the arrow sign conventions indicating when the member is in tension and when it is in compression. The method of joints consists of a number of free body diagrams of adjacent joints. The first joint must have only two unknown forces and one or more known forces. The unknown forces are determined by using the following equations of equilibrium. The sum of horizontal forces equals 0. The sum of vertical forces also equals 0. These newly found forces are used in the free body diagram of a joint. The load in each truss member is found by taking consecutive free body diagrams of joints throughout the complete truss. This is shown in the figure below in steps 1 through 7. Take some time and review each step, though note that more detail will be provided in future examples. The method of sections is used to solve for the force in a member near the middle of a truss. It allows us to avoid the comparatively more time-consuming method of joints. This method consists of cutting a truss into two sections by cutting through the truss where a member force is required. One section is then discarded. A free body diagram of the remaining section is drawn. On this free body diagram, we show a tensile or compressive force where each member was cut. These are equivalent forces that have the same effect as the section that was discarded. Suppose that a truss member, cut in two by the method of sections, had been in a state of compression. The free body diagram will show a force pushing on the remaining half of the member. Only three members are usually cut at one time, although a parallel solution is possible where four or more members are cut. In the previous truss problems, the truss members were two force members. There was either a tension or a compression force acting at each member. The force of a member on a joint had the same direction as the slope of that member. For this reason, we could draw free body diagrams of individual joints. Free body diagrams of joints cannot be used when the members have three or more forces acting upon them. A three-force member is subject to bending, and the force that it exerts on the joint no longer has the same slope or direction as that member. Therefore, the free body diagram is drawn of the member and not of the joint. A frame consists of a number of members fastened together so that each member has two or more forces acting on it. Determining these forces consists of drawing free body diagrams of individual members of the complete frame. Consider the diagram shown here. The truss pictured cannot be solved using the method of joints or the method of sections. Why? Here are some hints for solving problems involving trusses. 1. You typically have two choices as to where to begin a truss problem. Either a free body diagram of a joint where force is given, or a free body diagram of the complete truss to get more external forces. 2. Be ready to spot zero force members since they can simplify and shorten complicated looking problems. 3. Keep your free body diagram large, well labeled, and ensure that your calculations begin opposite of and to the right of them. Four, when using the method of joints to solve for all of the loads in the members of a truss, try to work into the truss from several external points so that a single initial error will not be perpetuated throughout the rest of your solution. 5. Remember that a tension member pulls on both pins, whereas a compression member pushes on them. 6. A section line cutting through a truss usually cuts only 3 members, thereby avoiding too many unknowns, and it does not have to be straight but may take any path through the truss. 7. After sectioning a truss, draw a free body diagram of the simplest portion with known forces. Try taking moments about a point where two unknown forces intersect. This point can be on or off of the free body diagram. 8. The shortest solution in the method of members occurs when the first free body diagram incorporates both given information and what is required. If this fails to provide a solution, then draw several or all possible free body diagrams to see in which sequence they may be used. A free body diagram of the complete frame is often helpful. Nine. When drawing the free body diagram of a member that has a two-force member pinned to it, it is recommended that you not show the X and Y components, but rather a single force with the same slope as the two-force member. This will highlight the fact that there is only one unknown at that point and not two. And 10. Remember that for internal forces between connecting members, if you switch the free body diagram, you also switch the direction of the forces of that new free body diagram. Homework. Read Chapter 5 from pages 157 to 182. Complete the practice examples and problems from the book, as well as those provided by the instructor. Also, participate in problem-solving sessions.